In this statistics lesson, we will be discussing frequency distributions, which are a great thing to organize and summarize your data. We will talk about how that works, what it looks like, and how you can interpret it if you are given one. All right, so a frequency distribution, sometimes called a frequency table, depending on which textbook you use, just shows you how the data is partitioned amongst several categories. We call those categories classes. So if we're looking at data about how long it takes you to drive to work, there'd be a 0 to 5 minutes and a 5 to 10 minutes, and they kind of have the data partitioned out that way in categories or classes. And then for each of those classes or categories, you will show the number of people who fell into that category. So they're very basic. In elementary school, you probably did these, and they called them tally charts. It's the same thing. All right, here are some definitions. Within our frequency distribution, we are going to talk about these classes, but they're going to have limits. They're going to have a lower limit, and they're going to have an upper limit. And that tells you the smallest number and the largest number that can belong to that class. And there are going to be some boundaries on those limits. So, how are we going to round if we have some decimal answers? Are we going to round those? How are we going to do that? So that's what those class boundaries are. Each class will have a midpoint because there obviously is a lower limit and an upper limit. So we'll take the average of those two numbers, and that will be our midpoint. And then the width is just the difference between those two consecutive lower limits, not between the upper and the lower. A lot of students get that confused, but you're just going from two consecutive lower limits of two classes right in a row. So the procedure for constructing one is very simple. You're going to decide how many classes you want, and this could be any between 5 and 20. Usually they will tell you how many classes they want, so it kind of makes it easy. But if they don't tell you, anything between 5 and 20 is fine. You are going to calculate your class width. And again, you just take the maximum data value minus the minimum and divide it by that number of classes, and that will tell your class width. And I have the approximate sign because sometimes you're going to round it up to a more convenient number. Like if you're talking about time and you get a class width of 12 minutes, well, 12 minutes doesn't really make sense when we're talking about time. So maybe you'll use 10 minutes, maybe you'll use 15. And if you are, it definitely is better to round up. So round up to, instead of using 12, use 15. Once you've done that, you're going to choose the values that you're going to work with for your lower limit. And then I choose all the lower limits first. And then I go through and I do all the upper limits for those classes based on the class width. And again, this will be a little bit easier when I show you how we do it. But so we're going to list those lower class limits, and then we're going to, once we have those classes all set out, then we're going to take a tally of how many data points fall within each one. So for example, here is a list. So over here on the left is just the daily commute times that I randomly got from people who live in Los Angeles. Okay, and there's quite a few of them. And then we're going to take this list and we're going to turn it into this list over here on the right. This is a tally chart. Notice we've got lower and upper limits, so 0 to 14. There's our lower and upper limit for our first class, and then 15 to 29. And then it has the frequency for each. So this is getting turned into this. So we're going to go through the process of how. And notice this one says use 7 classes. So 1, 2, 3, 4, 5, 6, 7. Notice there are 7 classes. So we're going to turn this data, all this raw data, into this distribution chart over here on the right. Oops, too fast. Okay, so step number 1, they've already told us they want 7 classes, so that makes it easy. We're going to calculate that class width. So we took the maximum data value, which was a 90-minute commute, subtracted the lowest, which was 5, divide that by 7, and we get 12.1. So we're going to round it up to 15-minute increments because 15-minute increments are definitely an easier way to go about that. So if you start with 0 as your lower class limit, because you may have someone that says 0, like if you take another person and they work from home, obviously they don't have a commute time. So we're going to start with 0 as our lower limit, and it's very convenient to start with 0. Let's just be honest. And then since the class width is 15, that means the start of the next class will be 15. So 0 and then 15, and then the third class will be 30, and the fourth class will be 45. So we always do those lower limits first using that class width. So then your chart will look like this once you've done that. So here's my lower limits, and then we can do the upper limit. So notice, if this lower limit starts with 15, we know this class before has to end at 14. So I can put those in. 15, 1 less is 14. 30, 1 less is 29. 45, 1 less is 44. So then we can fill in those uppers. And then once we have the uppers, all we have to do is go through and go look at our raw data and tally everything up. So in the end, this is what you'll end up with. So here's your lower and upper class limits, and then the frequency. Next class, upper and lower, and then the frequency. And we just repeat that process for the whole thing. So it's not difficult. It's just you have to be really careful about every little step you take in the process. For example, let's do one together. Okay, so let's say this is my frequency distribution. All right, so use the data above to construct a frequency distribution with 6 groups. Okay, so the first thing I have to do is the upper minus the lower. See, I want to find out what I'm working with. So let's see, the largest, luckily these are in order. If you go down, notice if I go down, they're all in order if I go down the columns. So I have 65 minus 12. All right, so that gives me 53. And then I want to divide this into classes. And it said to use 6 different groupings. So I'm going to have six categories. So I'm going to divide that 53 by 6. And that turns into 8.3333333333. So I'm going to round that up to 9, just because 9 is a little bit nicer number. All right, so when I'm making my chart, I need a lower to upper, right? That's my classes. And then over here, I'm going to need a frequency. And I'm just going to use FREQ for that. Okay, so we are going to start. Notice it starts with 12. So you can start with 12, you can start with 10. Since this data is inclusive, I would just start with 12. So I'm going to start with 12. 12 plus 9 is 21, plus another 9 is 30, plus another 9 is 39, plus another 9 is 48, plus another 9 is 57. So there's my uppers. Okay, and now I can do my lowers. Now, if this is 20, then my upper here would be 20. If this is 30, this would be 29. If this is 39, this would be 38. Since this is 48, this will be 47. Since this is 57, this will be 56. And then this is the last one, is usually where students struggle. So if you look, we're just adding 9 over here as well. 20 plus 9 is 29. 29 plus 9 is 38. So you can just take this 56 and add 9, and that will give you 65. So use those patterns to help you finish this out. So there's my classes. And then I just have to go through and count. So how many data points do we have between 12 and 20? And there are 8. How many do we have between 21 and 29? There are 6. How many are there between 30 and 38? And this is nice about having it in order. So I would definitely encourage you to put your data in order. Oops, put it in the wrong space. Have your data in order. Before you get started. It makes your life a lot easier here. 6 between 39 and 47, that is also 6. Between 48 and 56, there's 2, and between 57 and 65, there are 2. So as you can see from this frequency, notice the bulk of our data is here at the bottom. Okay, especially bottom heavy in that very first category, that first class. And then we've got the bulk of it here, and then we got a couple hanging out on the high end. So this data I can see is a little bit skewed. Okay, down to the lower numbers. So that's something I might want to keep in mind for later on when I'm working with it, doing my analysis of the data. There are other things that I can discuss here. I can talk about class boundaries as well. That's another, and midpoints. So let's talk about boundaries next. So if you're talking about boundaries, how do I decide what's 12? So you have to decide how you're going to round. And most PowerPoints, most Excel spreadsheets will always round up 11.5. Anything 11.5 or higher would get rounded up to 12. So usually you're just going to start there. So that's your class boundary, and you're just going to do this for each one of these. So what's 21? Anything that's above 20.5 or higher would be 21. Anything that's above 29.5 or higher would be 30. So you just repeat that process for all of those lower limits. So 47.5 and 56.5. So there are your class boundaries. They go, notice the class boundaries go with your lower limits, right? How am I going to round to make those lower limits? Your midpoint is just the average of these two. So 12 plus 20 and divide by 2. So it's 32. 32 divided by 2 is 16. So that would be my midpoint of this first class. And then you would repeat the process for each of those. 21 plus 29, and then divide by 2 would give you 25. 30 plus 38, and then divide by 2 would give you 34. 39 plus 47, and then divide by 2 would give you 43. 48 plus 56, divide by 2 would give you 52. And then 57 plus 65 divided by 2 is 61. So there would be your midpoints for each of the classes. And make sure if you look here, notice that the class boundaries are all 9 points apart and the midpoints are all 9 points apart. There's always these patterns that you can look for when you're doing these frequency tables. So that's how you do a frequency table. It's not horrible. It's just you have to, make sure that you're not making any simple arithmetic errors. Statistics will also use what they call relative frequency distributions. Now, relative in math just means percentages. So you're going to do exactly the same thing, but rather than listing the frequency, you're going to talk about the percentage of each category. So to find the percentage, you just take the frequency and then divide it by the sum of how many data points you were using. So if you're using 50 data points, you would just take that frequency for that class, divide it by 50, and then multiply by 100 to make it a percentage. It's important to notice that when you do a relative frequency distribution, that the sum of those percentages should be very close to 100. Now, sometimes they might be 101, sometimes they might be 99, depending on rounding error. So just know that it has to be really, really close to 100. If you get 105, something's really wrong. But if you get 99, you're fine. So I did that for the last chart. So rather than having the frequency here, I took each number, divided it by the total number of data points, and then multiplied by 100. So this would be the same chart that we just did. So for the commute time. So let's walk through our example that we did. So here's our example. Where we had our 12 to 20 is our first class limit. And let's talk about how we do relative frequency. So the first thing I have to do is I have to add up all my frequencies. And there are a total of 30. And you could have counted that from the original 2 as well. There were 30 data points. So we've got 30 data points. So I would take 8 divided by 30 and then multiply by 100. And that gives me 27%. Okay, take 6 divided by 30, multiply 100, that gives you 20%. And all of these are 6, so all of these are all going to be 20%. And then 2 divided by 30, multiply by 100, round to the nearest percentage. So those will both be 7%. So notice when you add these up, they add up to 101%. Which is okay because we had to round a couple of the numbers. So anytime you have to round, there's going to be some error there. So don't be surprised. But if you add them up and they add up to 105, you've really done something wrong. So just be careful with your rounding. Maybe go, if it makes you feel more comfortable, maybe go another, 0.1%, do a decimal in there if it makes you feel a little bit more comfortable. All right, the main thing that we use frequency distributions for is one, to just look at the distribution of the data to see, is it more towards the beginning, more towards the end? Is it evenly spread out over these classes? But it's also really good when we're comparing two sets of data. So let me go to this example. This is the frequency distribution, a relative frequency distribution for both New York and for Boise, Idaho. So New York City and Boise, Idaho side by side. And as you can see, there's some similarities here. So if you notice, most of the commute times are around an hour or less. For Boise, it definitely looks like it's 45 minutes or less. So they both have similar patterns, whereas most of the commute times are shorter than the longer. But you do have a couple of people who are making super long commute times, both in New York and in Boise. So we could spend a lot of time talking about the differences and the similarities of the two data sets. But I think when you do this side by side, especially with the relative frequencies, because if you use just frequencies, it's hard to tell because maybe the New York data set had 100 data points and the Boise set only had 25. So you have to take that into consideration. That's why you really want to work with those relative frequency ones, because then you have a better idea because you're looking at percentages and not actual just data values. People might expect that these would be very different because of the size of the city. Boise is a much smaller city than New York City, but as it appears, they're pretty similar. So again, I could make 27 different questions about this one slide, but just so it gives you a general idea of what's happening. There's something else also called a cumulative frequency distribution. So if you just want to look at how many people were less than 15 minutes, it would be 6. If you want to do less than 30 minutes, you would add up all the people from 0 to 30. So you'd add up all those and then put them in this chart. So notice as this chart goes along, by the end, this should be your total number of data points when you get to the end. Total number of data points. Because less than 105 is everybody that we talk to. Everybody had 105 minutes or less. So we're going to create one of these cumulative frequency charts for our data set that we were working with. All right, so here is our upper and lower, and here's our frequency. Okay, so cumulative. So everybody under 20 would be 8. There's 8 people, right? Then how many people under 29 or under? You would add these two together. So 8 plus 6 is 14, and put that here. Okay, and then you're going to, as you go through, you're just going to add the amount here. So 14, then we're going to add these 6 people, and that gives me 20 people who are 38 or less. And then we're going to add the next 6 people, so that would give me 26, and that's the people who are 47 or less. And then add the next 2 people, which is 28, and then the last 2 people, which is 30. And we should end up with 30, right? Because that's how many data points we had in our set. We had a total of 30. We can also use this data and do a relative cumulative. So cumulative relative frequency. I know lots of words all at once. Okay, so cumulative means we're adding up. Relative means percentages. So we take our relative frequency chart that we had before and then just add those up. So this group would be 27. So 27% were 20 or less. Okay, add the next 20, that would give me 47. So 47% had 29 or less. Add the next 20%, that gives me 67. So 67% were 38 or less. And then repeat the process for all of those. And then add 7 gives you 94. And then add 7 gives you 101. Now, we knew it was going to add up to 101, right? Because we already talked about that earlier. So that's cumulative and relative at the same time. So you can do all kinds of different frequency distributions, just depending on what your needs are for your data. Now, there are some things that we need to talk about understanding how these frequency distribution works. Later on, we are going to talk really in depth about what we call a normal distribution. Normal distributions have frequencies that start low, they increase, and then about the middle of the middle classes is going to be the highest frequencies we're going to see, and then they're going to decrease again, and they're going to be very low when we get to the last classes in our data set. It should be approximately symmetric. So we should have about the same amount. Like when you get to that middle, you should have about half of the data points on the lower end and half the data points on the upper end. And they should be roughly mirror images of each other on each side. So let's talk. Let me show you an example of what one looks like. All right, so here is a commute time chart that is a normal distribution. Notice it starts at 2, goes up to 18. So, and this is the very middle class, right? The very middle class that we talk about. That's 18, and then it goes down again back to 2. And notice these numbers are perfectly symmetric, 2 and 2, 4 and 4, 10 and 10, and 18 in the middle. So this is a perfect example, an almost utopian example of what a normal distribution will look like. And we are going to talk about normal distributions in depth later on. There's a lot that we can do with them. All right, if you have gaps in your data, especially if it might show that your data is from 2 different groups or 2 different populations. So, you know, maybe people who, if you're doing commute times, maybe there's a bunch of people who take a few minutes and then there's a big gap, and then there's a bunch of people that it takes them a long time. So maybe you got a group of people who live in the city right near where they work, and then you had a group of people who lived in the suburbs and had to commute in. So there might be different issues that come up. But the converse of this is not true. Data from different populations doesn't necessarily have to have gaps like that. So you could have a gap, you might not. It just depends on the data. So don't think that you have to have one. Here's a good example of talking about why these gaps happen. So I took a whole bunch of pennies, right, and I weighed them. And those show me the weights of my pennies. So between 2.40 and 2.49 grams. And then I counted up how many pennies weighed that much. And then I did each of those little classes. right? So very small changes. So I had to be very precise in my measurements. And I noticed I had this big gap in the middle. There were a bunch that had the lower and then a bunch that had the higher. And nobody in the middle. So why do I have this gap? Um, and some students know this. I didn't know this. I had to look it up because I wasn't sure. But it turns out that pennies were made differently. In 1983, they started making pennies differently. So before 1983, pennies were made of 95% copper and 5% zinc. And it resulted in lower weights because copper weighs less than zinc. But copper got really expensive, so they stopped using the majority copper, and they changed in 1983. The US Mint changed to having 2.5% copper in their pennies and 97.5% zinc because zinc was cheaper. So it turns out that it just depended on the year. So the pennies that were made after 1983 weigh more because they're made mostly from zinc and not copper. So if you have old pennies, they're actually worth some money. They're actually worth more than a penny. So if you have a penny prior to 1983, it is worth more than a penny because of the percentage of copper that it's made up of. So anyway, so that can happen in your data as well. So hopefully this has helped you learn a little bit about frequency distributions, and now you can go practice, and I will see you next time.